Mr. Anil Kumar Pillai is a member of All India Management Association. He is also member of Institution of Engineers, Association of Consulting Engineers. He represents Ramco Cements in various BIS committee of cement and concrete. He has presented many papers on blended cements, building materials, and he has been a very active speaker in various forms, spreading awareness uh, of his through his experience. And he has been invited speaker by many colleges and universities, and he has given lectures in various forms, including in Dubai, uh, Kumamoto University, Japan, Wollongong, and many other places. The list is very big actually. And he has served in companies like Trafalgar House, L&T, Cement Division, Ultratech Cement, Amrita School of Engineering. He has served SCMS Management Institute in Kerala, the Ramco Cements Limited from 2008 till date. And most importantly, other than cement, he is, I can say, like Virat Kohli in Indian team, among construction professionals, one of the most fittest, I can say, without any doubt. He is a long distance swimmer. He does sea surfing, stand-up paddling, and he's a yoga practitioner. And I can say, as I said earlier, he has probably set a benchmark for civil engineering industry in terms of fitness. And I think there is nobody who can come near to civil engineering industry, at least at this point of time. With all this small introduction, because his publications and all and his works are very big, we cannot encapsulate in a very short time. We welcome today's lecturer, Mr. Anil Kumar Pillai. Sir, welcome you, sir. It is an honor for us to host you on Qcrete platform. Thank you.
Thank you so much, sir, Kaushika sir, because you are yourself a master in concrete, and you have so wide experience having worked in concrete. I'm just going to present one of the components of concrete. In fact, in the process, of course, we also get to learn a lot of things about concrete. So thank you so much for having given us this opportunity. So let me just check whether I am able to share the screen with all of you. Is the screen visible?
Yes.
Now, the thing is that the basic purpose of this webinar is to talk about cement. So Kaushika sir told me that you just talk about cement, its properties, and whatever the customer needs to know about cement. So I will keep my discussion confined to cement. So nice to have all of you here. In spite of all your busy schedule, you are here. So please feel free to make your comments, because it's very important that we have a kind of interactive session. So at any point of time, if you feel that there is some disturbance in the presentation or the slide is not being seen, please alert me on that. So as all of you know, let me just start from the basic thing. We all know the next slide you are able to see,
Yes.
In concrete, we know that cement plays a vital role, but of course, in terms of percentage, it is less. So other ingredients are also there, like you have water, coarse aggregate, fine aggregate, but most importantly, chemical admixtures, which in fact alters the performance of concrete based on the requirement. So the first and the foremost thing that we at our organization do at Ramco Cement is that whenever we go to a customer, we ask them about the requirement of concrete first, because based on the requirement of concrete only, we need to look at the type of cement. Because when we look at the type of concrete or the parameters of concrete, starting from workability, in terms of how much slump is required, what is the slump retention time that is required, what is the compressive strength that is required, because most of the places they may need 1 day compressive strength, 3-day or 7-day, 28-day compressive strength. Whatever the requirement is, that we need to look at in clear terms. As far as the durability also, because many places we see that many construction professionals have also started evaluating durability through various tests. It can be through RCPT test, or it can be through water permeability test and all that. So there are various tests to evaluate this. So based requirement of concrete, we need to evaluate the type of cement. That is very important. So just to give you a brief overview of cement, how it was, all of us know that Joseph Aspidin, in fact, had literally, laid the foundation of cement, and it is a basic ingredient of concrete which brings together all the other ingredients. So that is the role of cement as such. Just to give you a brief overview, because when you look at cement as compared to other materials, cement is manufactured in a plant with clear-cut manufacturing process and with clear-cut quality assurance process also. And we have the, in fact, if you look at the Indian cement industry itself, you will find that the latest technology of cement manufacturing process is actually in our country. And we also have been in cement industry for quite a long time, and we have been able to bring in the latest manufacturing process. So just to give you a brief overview, so that from a customer's perspective, you must understand that how cement is manufactured. So starting from the quarrying, what you call the limestone mining, you will find that there are areas which is rich in limestone mines. Both high grade as well as low grade limestone would be there in the same limestone belt. And there are other ingredients which is also being added, and it is being crushed, ground, mixed and blended. So what is important is, if you want to manufacture a cement of consistent quality, the variations right from the raw materials should be evened out, and all out measures should be there to find, to ensure that the blending is being done, or we have different mechanisms for that. Like we have the CF silo and we have the stacker reclaimer, which in fact ensures that the standard deviation of the raw material is brought down. Because the challenge is the challenge is to manufacture a cement with minimum variation. You can manufacture a cement of very high compressive strength, but can you maintain it over a period of time? That is very important. And that is what you will find the various steps, starting from quarrying to crushing, grinding, mixing, blending, and then you actually preheat, and then you fire the kiln. That is how it is, the process is being done. And then the cooling takes place. Both the, the kiln firing at a very high temperature of 1500 degrees centigrade, and then the cooling to 100 degrees centigrade, it all needs a lot of monitoring. And the clinker is formed, which is being ground into fine powder, and it is being mixed with gypsum. Clinker is mixed with gypsum to form ordinary Portland cement. And when you add a blending material like fly ash or slag, you get the blended cement like PPC or slag cement. So this is the kind of the thing. And most importantly, you will find that all out steps are being ensured to control emissions from various steps in manufacturing process, right from mining till packing. So this is just a brief overview of what is happening. You can see the diagram itself. You'll find that the limestone quarrying is being done. Stacker reclaimer is there to even out the variations. The raw mill silo, the preheater and the pre-calciner. Because before getting into the kiln, the entire raw material is heated to a particular temperature, and then all the, and it is this is how the this thing is happening. The cooler is there, the cement mill, and this is a typical cement plant. So this is how the limestone mines will look like. What is important is once the limestone is being mined, rather than leaving the mines like that, we always have the practice of again doing afforestation there, so that the whatever we are getting back from the nature, we are giving it back through the process of afforestation. So this is what limestone mines looks like. Stacker reclaimer that I was talking about, the raw material, how it is being stacked and then reclaimed, so that the variations is evened out. The cross belt analyzer, in fact, is a kind of online analysis of the various raw material. You can find out as to what kind of composition is there, and necessary changes can be made online itself. So this is the kind of mechanism that is there to have a better quality control over the quality of the cement that is coming out. So this is the raw mill, and you have the CF silo, continuous flow silo, where continuous homogenization takes place. Again, the objective is to bring down the variations in the raw materials. Then the preheater unit is there, where it is being heated to 700 to 800 degrees centigrade. The kiln, as you can see, and this is what the clinker. So the properties of clinker is very important. You could see the the clinker is manufactured in such a way that the compound composition and the oxide composition, the compound composition is in such a way that the properties of cement is maintained. That is how you will find that there are different types of cement. Even within a particular type of cement, you can actually fine tune the properties that is needed. That is why we have this motto of right cement for right application, because by virtue of the clinker chemistry itself, you can change the properties of cement. So you have the ball mill and various kind of grounding mechanism is there, through which you get a cement of the required fineness. So that is what it is. Roto packer, the kind of packer that is there to ensure that the cement is manufactured in properly. So this is just an indicative value of because for most of the concrete users, they would be interested in knowing what are the oxides basically. So you'll find that lime, silica, alumina, iron oxide, and other minor oxides would also be there. But what is of important is the interplay between the lime, the calcium oxide, and the silica. That is very important, which enables the formation of compounds in cement. And these compounds in cement actually determines the chemistry of cement. So that is where you'll find that when you add a chemical admixture, it is very important that you study the cement admixture compatibility. And the cement admixture compatibility to a great extent is dependent on the oxide as well as the compound composition of cement itself. The tricalcium silicate, just to give you, I'm not going into the chemistry of this, but the thing is that we need to understand that tricalcium silicate is nothing but it will give you the early strength, and dicalcium silicate is nothing but which gives you the later strength, and tricalcium aluminate the 1 to 3 day strength. But the thing is that this particular compound tricalcium aluminate is limited, and because of tricalcium aluminate, we add gypsum in cement manufacturing process so that the cement setting time is regulated. And then you have the tetracalcium aluminum. So these are the compounds in cement which determines the later strength and the chemistry of cement itself. So you have different ways of actually determining these compounds. We have the traditional method of box method, which is not used nowadays. But then there are rapid method of estimating the composition of cement by various methodologies which are there. We also have X-ray diffractometer at our various plants as well as at our R&D units, which helps us in determining the various compounds of cement. So just to give you an idea, what happens in cement manufacturing process is the oxides combine amongst themselves in a particular manner so that the manufacturing process is designed in such a way that you have the required percentage of the various compounds of cement, which gives you the strength properties and other properties of cement. So that is how the chemistry of cement in brief is there. So this is what you need to understand, that before actually starting the concreting process, there should be a kind of process in place wherein you do the trials at site on a regular basis. It is not enough that we do the trials in the initial stages and then later on, you don't do the trial, because what happens is that if you're having a major concrete pour, it is always a good, good practice to have this process of trials in place at site, because we have seen in many places when this is not in place, they land up in issues and all that. So this is what, as far as the oxides and compounds are concerned. So till this time, if there are any, any queries that you have, please feel free to, chip in, because we have just touched upon the oxides, the compounds, compound composition of cement. So if there is anything you want to know or anything, any comments from your side, a kind of, so that, I know that all of you are there, but then some kind of intervention from your side. So this is what all about, how do we actually get the early strength and the late strength. So shall I go ahead? Any responses?
Sir, what I suggest, no, sir?
Yeah.
You finish and last 10 minutes we'll give for
fine.
Otherwise, it will obstruct your flow.
Yeah. So this is the oxide and then the compound composition. And again, to reiterate, early strength, later strength, and this also gives some kind of early strength contribution in that. And this is very minimal. And to evaluate the compound composition, you have different methods that we follow at our cement manufacturing process. Now, before checking the quality of the cement, this is very interesting. The first and the foremost step that we do is the normal consistency of a cement paste. And let me tell you that we should not evaluate the quality of cement only based on NC, because there is no limit as such mentioned by the Indian Standard Code as far as NC is concerned. NC, normal consistency of the cement, is used to determine the amount of water that can be used to find out the setting time, the initial setting time, the final setting time, the compressive strength of cement. But many places what we have seen is that they think that the NC should be within this, it should be 27, 26, 28. If it is not there, then there is some problem. No, it's not like that. On normal consistency, there is no limit at all as far as the Bureau of Indian Standard is concerned. The normal consistency of the cement paste is a laboratory test, which actually helps us to determine the amount of water that is to be added for the other tests that is involved. So this is what you will find that when it is allowing the Y-cut plunger to penetrate to a point of 5 to 7 mm from the bottom of the Y-cut mold, that is what the NC is actually determined, and it determines the quantity of water to be mixed for a given cement to give a cement paste of normal consistency, and can be done with the help of Y-cut apparatus. And Y-cut apparatus can be used to determine the initial and final setting time also. So if your NC changes, if there is a mistake in measurement of NC, then your initial setting time value, final setting time value, your compressive strength of cement mortar can change. So it is very important that you measure the NC correctly. That is why in many project sites, when we say that if you are attempting testing of cement at the site, you need to be very careful as far as NC is concerned, because the moment there is an error in the measurement of normal consistency, you will find that the other parameters changes. So the initial setting time of the cement helps you to find out, and the final setting time helps you to find out the workability. It affects the workability of concrete and the placement of concrete to a certain extent. Of course, the soundness is also there. The soundness of cement, we have two methods, the dechattier and autoclave, which refers to the ability of the hardened cement paste to retain its volume after the setting without delayed expansion. So that is what it is all about. Unlike concrete testing, concrete testing, as all of us know, is done on 15 centimeter by 15 centimeter cube, but this is the cement mortar strength is actually done on 7 by 7 centimeter cube mold, and it is basically done under standard conditions. So the standard sand which is available from Tamin is being used. So the basic idea of having a standard test is that it becomes easier for us to evaluate the various types of cement that is available in the market. So when you have a standard test like this, you can compare the types of cement that are there. So this can be useful for a customer, because if a customer wants to evaluate the quality of cement, he can always give it to an enable accredited lab, or otherwise the kind of test that can be done, and this can be used to compare the compressive strength of various cement. Why I'm saying this is because when you look at a problem in concrete, you can dive down deep into each of the ingredient of the concrete to find out where the problem is or where the challenge you have faced. So this is what, because the compounds in cement itself hydrates and it reacts with water to form different compounds, and you will find that it is on the basis of the hydration of various compounds of cement that it gives strength to the concrete or to the cement itself. So this is how the term C3S and C2S don't go by the formula. In the cement chemistry, the C represents calcium oxide, S represents SiO2, that is silica, and H represents water. So the C3S, C2S, they actually form what we call the calcium silicate hydrate, and the calcium hydroxide is also generated in the process of hydration of cement with water. So that actually is very important to note, because what is desirable is the calcium silicate hydrate. So whenever you look at a concrete, inside that, if you look at the cement paste, the undesirable portion is what you call the calcium hydroxide. So that should not be there, because the moment that is there, it affects the durability of concrete itself. So the CSH gel has to be increased. So that is why you will find that you need to have a measure to remove the calcium hydroxide so that the durability of the concrete is enhanced. So hydration of C3S, as all of us know, because C3S or the tricalcium silicate, which gives the early strength, logically when the tricalcium silicate reacts with water, the reaction would be very rigorous, more heat of hydration would be there. and it's responsible for the early strength of concrete, and more quantity of calcium hydroxide also comes out. And of course, C2S is less rigorous as compared to C3S, and it is in comparison to that, and you will find that calcium hydroxide would be lesser. So this is what happens in case of sulfate attack, and this reacts with C3A. So that is why you will find that when the sulfate attack is predominant and you don't have any chloride attack, you can go for sulfate resisting cement, where your percentage of tricalcium aluminate can be brought down substantially, so that it becomes a SRC cement. So basically the mechanism of sulfate attack is like that, and that is where you will find that in tricalcium, in sulfate resisting cement, we try to decrease the percentage of this one. So C3A. Basically, you will find that what we have seen at the practical sites, you will find these two terms actually, the fault set and the flash set, that is happening. And it is a rapid development of rigidity in freshly cement paste actually, without the evolution of much heat. And plasticity can be regained by further mixing. So this is nothing to be alarmed about, but sometimes it may happen. And flash set is the rapid development of rigidity, but with the evolution of considerable heat. So plasticity cannot be regained as far as the flash set is concerned. So it can occur due to various reasons. It just as far as cement is concerned, it can occur due to this. So this is what setting behavior in concrete can also be due to the nature and quantity of admixture, and is different from setting time of cement. So hydration process in concrete speeds up because of number of other reasons also. So this is just to give you an idea of what is the difference between fault set and flash set actually, which sometimes happens. So if you are reasonably certain that the flash set has occurred, your best advice to finish the concrete as soon as possible without retempering or remixing, because of the simple reason that flash set, the plasticity cannot be regained. So this is what it is. And just to give you an idea, taking back you to the manufacturing process, it is very important that the temperature is maintained at various stages while the clinker is coming out. And this is how, because the maintaining of temperature at the various processes is very important. And if you look at a cement test report, you have a physical requirement is there and a chemical requirement is there. And in the physical requirement, you will find that now that 43 grade and 53 grade OPC has been combined into one code now, IS 269, you will find that as far as 43 grade is concerned, there is a minor change which is not in. There is a upper limit of the strength also, that is 43 plus 15, 58 MPa. It should not go beyond 58 MPa. And these are the parameters you will find as far as the cement is concerned. You will find that fineness is there. The fineness should not go below this one. Earlier we had the method of sieving the cement, but nowadays we have what we call the Blaine's air permeability apparatus, where it is measured in meter square per kg. So it's a much more sophisticated method than the conventional sieving method, where you have a limit of 10%, it's a particular percentage retained on the 10 micron ISC. But here it is measured in Blaine's air permeability apparatus. Then you have the setting time. Of course, the BAS states between 30 and 600 minutes. So you can have a cement that is being manufactured between these two limits based on this thing. And normally you will find that the initial setting time of cement will range between 150 to 200 minutes. And final setting time somewhere around 180 to 300 minutes. That is how the setting time, initial and final setting time of cement is there. Leach adhere expansion and autoclave expansion is basically done to measure the soundness of cement, so that a control over the expansion of the cement mortar is there. So that is how you will find that by leach adhere expansion, it should not exceed more than 10 mm. If it exceeds more than 10 mm, means it cannot give a durable thing. So it is very important as a customer that you look at these parameters whenever you get a cement test report. Look at the fineness, look at the setting time, what is mentioned in the cement test report, what is the leach adhere, what is the value, autoclave expansion, and you have the 3-day, 7-day, 28-day strength that is mentioned, which of course most of us look into it. But then it is also interesting to see the other parameters as far as the cement is concerned. Then you have the LSF is there, lime saturation factor, which is not there in blended cement. Basically, lime saturation factor, this parameter is actually there in ordinary Portland cement, and then you have the alumina modulus. The insoluble residue is something that you will find in cement test report, which is mentioned. It is very less in ordinary Portland cement, whereas in PPC and you will find that IR limit would be higher because of addition of fly ash. And you have the magnesia percentage and all that sulfuric anhydride, which is coming from gypsum. Total loss on ignition and chloride content. So as a customer, if you are given this cement test report, you get a fairly good idea of what is the physical requirement of cement and what are the chemical requirement of cement as per the code and as per the particular cement is concerned. So this is what you will find clinker, gypsum and fly ash is being ground to give you the Portland post-lunar cement. And here even in Portland post-lunar cement also you can get a cement of higher compressive strength by changing the chemistry of clinker, as well as by changing the chemistry of cement itself and by the way it is being ground. So that is why you will find that even in our own Portland post-lunar cement, there are various types of Portland post-lunar cement in terms of strength gaining properties. So if you want a PPC with only low heat of hydration, you can go for it. Or you want a PPC having a low heat of hydration as well as higher compressive strength, you can have a cement which is being manufactured based on that. So this is what it is all about. And if you look at the test report of Portland post-lunar cement, the fineness would be higher. It would be close to 300 meters square per kg, whereas for ordinary Portland cement, the limit is stated as 225 meters per kg. The basic idea is that if you have a higher fineness, the reactivity would be much better. And again, you will find that even for Portland post-lunar cement, you will have setting time, initial and final setting time, the leach at layer expansion, maximum 10 mm, autoclave expansion of maximum 0.8 mm. Then you have the 16, 22, 33, which is as mentioned in the code, but we can always enhance the compressive strength of cement through various other measures. And here you will find the drying shrinkage is also measured, and the fly ash addition is there. Like say, for example, the cement manufacturing process, the minimum limit is 15 and the maximum is 35%. Now this limit is not there when you add fly ash at site. You can go in for a higher percentage, but this is only applicable in case of cement manufacturers. So here you will find the insoluble residue. In fact, this is just a representative value. But the thing is that there is a formula for insoluble residue that is in terms of the fly ash percentage, which, if the fly ash percentage is higher, your insoluble residue will also be higher. So these are some of the essential tests that can be done on cement. Specific surface is what we call the fineness, the consistency, the setting time, the soundness, the compressive strength, the particle size analysis, which is not mentioned in BIS, but we do it on a regular basis because based on the particle size analysis of cement, you can in fact control the quality of cement itself to a greater extent, and you can monitor it. And this particle size analysis and the chemical analysis by XRF and XRD is not in the purview of BIS itself. They are not saying. But if we adopt this three method of testing cement, we are able to actually look at the way cement can be customized. Because customization of cement is only possible if you have a detailed analysis and study of cement itself. So there, the particle size analysis and the chemical analysis by XRF and XRD plays a vital role. So this is what, as far as the fineness of cement is concerned, the Blaine's air permeability apparatus, the consistency of cement is measured like this. And here, normally the error occurs when you actually mix the cement paste. And it all depends on the kind of pressure that is being given to the paste at the time of measuring the normal consistency. So this is how normally the errors occur at this stage. So this is what I was mentioning at the initial thing. And even initial setting time of cement and initial setting time of cement and setting time of concrete, we should not get confused, because the setting time of concrete may not be the same as setting time of cement, because setting time of cement you have only the cement mortar, whereas setting time of concrete you have the other ingredients also, wherein again the setting time of concrete is being measured by a different apparatus altogether, whereas setting time of cement is this one. So you cannot exactly have this. So this is what the soundness actually of cement mortar that we are measuring. It is dependent on the various compounds that are there, especially the free lime or the calcium hydroxide that is there can always affect the durability of cement. So the soundness of the cement mortar by means of leach at clear or autoclave helps us to determine whether the expansion is within the limits or not, and it is very important. So just to give you this thing, in cement itself, we are measuring the durability of cement by these two methods, leach at clear expansion and autoclave, just to see how much expansion is taking place. So this is what it's all about, both the tests. And the compressive strength is also measured using this thing. And particle size analyzer, we have, in fact, we have the Silas particle size analyzer just to see the cement particle size from 3 to 30 micron, which is more reactive. And it is very important that we look at those range of particles of cement, because that happens because of the way the cement clinker is being ground. So that is where you will find the particle size analysis is coming. X-ray analyzer, of course, it is very fast way of analyzing the cement itself, and it can be done within a shorter period of time. And diffractometer helps us to look at the mineralogy of raw material and the quantification of free lime. It helps us in that. So this is how a cement quality is being monitored. So this is what all about I wanted to share with you. So if there are any queries, we can go ahead with that. So this is what I just thought about, sharing about cement, the properties of cement, the way it is being manufactured, the important parameters of cement. So I just wanted to confine myself to that. Of course, there are various challenges in concrete, as we know. So it's very important that we look at the cement consistency, the quality consistency over a period of time, which will give you an idea. But more importantly, when we look at concrete, we need to look at the variability of other raw materials also, which is very important. Because as we all know, when we get a particular type of concrete in the laboratory, whether we can actually have the same property in a batching plant. Sometimes the admixture dispenser can be a challenge because admixture dispensing at the lab can be much more controlled. And we also need to see whether the admixture dosage is changing, with the type of cement. And it's very important that whenever you change the source of cement, the trial with the particular admixture is very important, because without that, then you don't get the desirable properties. So this is what I thought I would share with you. So I just conclude my presentation, Kaushika sir. So this is what I share.
Yeah. Good evening, all the audience. If questions are there, you can post it and we can pick it up and ask our esteemed speaker today. Can you kindly post the questions so that we can ask Mr. Anil Kumar sir?
In fact, just to also add, each of the parameters of cement that we spoke about, whether it is fineness, initial setting time, final setting time, leach at clear expansion, autoclave, compressive strength, chemical parameters, magnesia, we in fact have a consistency chart also for each of these parameters. So that helps us to, see, because, how the quality is varying over a period of time. And generally, if you see cement from the same source, if you're taking, I think there should not be any challenge as far as the cement is concerned. So we have the consistency chart that is there over a period of time. The samples are being drawn at regular intervals of time, and these parameters are being measured. And our experience shows that even in major projects, I was just harping on NC because we had an experience quite a long. I do not want to name the institution itself, but they were looking only at NC, and then they were saying whether the cement is good quality or bad quality based on the NC variations. But NC is just normal consistency, is just a basis of determining the water content for other cement tests. That is what.
Anil sir.
Yes, sir.
One question has come to me on WhatsApp.
Okay,
Mr.
sir.
Mr. Joseph asks this question. Many cement companies
Okay.
advertise their cement as crack-free cement. Are they
Okay.
doing something special to their cement, or what is it?
See, as
Is
far
it
as
really effective? Is it really effective? He's asking.
okay, that is a very good question, because when you look at when we advertise as crack free or something like that, what happens is that as far as cement is concerned, if you want to reduce the cracks, it is by virtue of lowering the heat of hydration, and that can happen only by adding blending material. So the thing is that what we can do is that what we are doing to determine whether it is crack free or not, there is a test called shrinkage crack test, wherein you have a circular mold, you put the concrete in that mold, and then you can measure the deflections over a period of time, and then you can measure the probability of cracking based on the various mixed proportions as well as the various cement types. So if you are able to evaluate that cement by using the shrinkage crack apparatus, you will find that the probability of crack over a period of time can be evaluated. So one property, yes, it is a heat of hydration of cement which can be controlled to reduce the cracks, and it is possible. Of course, the other influencing factors are the workmanship practices and the way the mix is being done. And if there is too much vibration, or if the cement slurry comes to top, such type of cracks is not within the scope of the cement. But as far as cement is concerned, we can definitely measure the heat of hydration. We can bring the heat of hydration under control. But of course, the heat of hydration parameter as of now is not mentioned in the cement test report. It is not there as far as BAS is concerned. But heat of hydration is one critical parameter which helps us to determine whether the cement has a property of cracking or not. So we can decrease the probability of cracking by decreasing the heat of hydration. Yes, sir.
Nandakumar, any questions you have found? Any questions are there from the audience? Nandakumar?
I didn't find any questions. I actually put in a message. If they have questions, they can raise the questions in the question box.
Sir, one more question this person is asking me on my WhatsApp. Actually, I don't know why he's not able to post here.
Okay.
Mr. Joseph, he's asking that other countries in US and all, they are casting cylinders. Okay. And since cylinders to cube strength, you have to divide by 1.25.
Correct.
Or you can say the cube strength is factor is there.
Yeah.
So that means to say the strengths, if USA or ASTM standard 52.5 means that strength is greater than the comparative Indian standard cement of 53 is asking.
So that is.
I hope what I have just.
I know, because we are comparing the standards actually.
Yeah. Yes.
Like if you look at ASTM standards or EN standards or our standard, it's all nothing but a testing methodology. I think we cannot say that if suppose there it is coming higher strength, here it is lower strength, not like that. The thing is that there are standard methods of testing, and those standards are defined based on this thing. So if you want to say that a cement manufactured in India is fulfilling the ASTM standard, then we have to go and follow the ASTM method of testing. Rather than comparing the standard and getting confused whether our BAS limit is higher than the ASTM limit, we can always test the Indian cement based on ASTM standards, because there is a procedure of testing. Like say, for example, in our Indian standard, we have the IS 4031, which is the method of testing of cement, like starting from NC to initial setting time, final setting time, compressive strength, and all that. So similarly, there are methods of testing in ASTM. So we can always see whether the cement is fulfilling the ASTM standards or not, rather than comparing the standards per se, saying that whether this is higher or low. But normally, I think because the method of testing changes, so it is very difficult to do that. But of course, we can test the cement as per the particular standard. That is how we do. Whenever we have to export a cement, what the customer asks is that very simple, direct question: whether your cement fulfills the standards or not. Even if you export cement to the nearby country also, they go for the international standards. So whatever the international standard says, we will follow the method of testing of that standard and then say, whether it fulfills that or not. So that is the only I think, a clear-cut way of evaluating the quality of cement as per that standard.
So thank you. I hope he has heard actually. I don't know why he's posting on WhatsApp. Sir, one Kanishka, Nagireddy sir. Nagireddy sir from maybe Hyderabad, should be Hyderabad. Nagireddy sir, can you unmute him? Let him ask the question. I cannot understand this question. Kanish, can you unmute Mr. Nagireddy sir?
Yes, sir, I'm finding it.
Namaste. Namaste. Can you please ask the question, sir? Namaste.
Yes, sir. Nagareddy sir is on the contributors. Now he can unmute the mic and he can ask the question.
Yes, sir.
Sir, my question is, present all companies are providing the PCC cement, sir.
PCC cement, sir.
Yes, sir.
Yes, sir. Portland composite cement you're talking
Composite
about.
cement, sir.
Yes,
Yes, sir. Right now, this is majorly all companies are providing, sir, in the market.
Okay.
How we inform the customers about this PPC and PCC, sir?
Okay. Okay. Sir, one thing is there, to broadly classify, PPC is nothing but you are adding fly ash.
Yes,
PSC you are adding slag, and PCC you are adding both in particular thing. So the thing is that all these three cements from a durability perspective, it is very good. But what I would suggest is that before, a better way to determine the type of cement that is to be used in a particular concrete is to understand what are the concrete properties that you need. Say, for example, if suppose you need a high durability, this thing, so you can go for any of this blended cement. But what is the degree of durability that you need? You can always do one thing. If suppose it is a critical project, and if you are getting all the three type of cement, then you can evaluate the durability based on the durability test of concrete by using any of the cement. But for a normal customer, I think if suppose he is executing his residential building, there I think he can go for any type of blended cement that is available. But only advantage is that PCC is the latest entrant in the market, the Portland composite cement, where there are a number of tests that is being done. Whereas PPC and PSC is there already in the market, and number of tests on durability is being done. So I'm not saying that PCC is less inferior to that. Only thing is that you have both fly ash and slag in PCC cement. So for a critical project, I would advise that you determine how much durability you need, because durability requirement is different for different projects. Like say, for example, if you take the metro project, some of them do by water permeability as well as the RCPT test. And if it's a very critical project, they may go in for a carbonation test also for durability. So you can take any of these things. And normally concrete for such thing, of course, is being added by adding OPC and then fly ash or slag at site itself. But as far as the type of cement is concerned, if you are very particular about selecting this type of cement, then I think you define the degree of durability that you need for the concrete, and then accordingly going for the selection of this. But all the three cements are good as far as the durability criteria is concerned.
Sir, another question, sir.
Yes, sir.
In many individual houses and normal apartment buildings, they are using IWP liquid, sir.
Okay.
So many.
Correct.
What is the advantages and any disadvantages from this?
Okay, that again I will see. Suppose you want to understand the role of IWP. IWP basically is integral waterproofing compound, which actually reduces the water cement ratio. It works most of the IWP. So what you should do is that if you are planning to use IWP, what I would advise is that you make a control concrete without IWP, and you make a concrete with IWP with say 200 ml per bag or something, and then you see if there is a difference. And if suppose it is reducing the water cement ratio, then you can go ahead with that. Because it is normally IWP is being used in individual house building. So there, by virtue, and IWP will only work if you are reducing the water cement ratio. Suppose if you are using 0.5 water cement ratio and you use IWP and still maintain 0.5 water cement ratio, there is no point.
Yes,
If
sir.
0.5 is reduced, say for example 0.4 and then you use IWP, there is some logic in it.
Okay, sir. So that's why only some of the material is aggregate, sir. Due to this, I look,
Which is
0.5 water,
some aggregates.
total material should be segregate, sir.
That happens if you are not reducing the water cement ratio, sir. Because if you are using 0.5 water cement ratio in case of controlled concrete, and when you are using IWP, you should reduce the water cement ratio. You got my point, sir.
Okay, sir. Okay, sir.
You're
Thank you,
talking
sir.
about segregation and bleeding in general, or you're talking with reference to IWP?
With reference to IWP, sir.
With reference to IWP, if you don't reduce the water cement ratio, there will be definitely segregation and bleeding, sir. You got to reduce the water cement ratio.
Water cement.
Yeah, then only you will get the full benefit of IWP.
So there is.
Thank you, sir.
Thank you. I think Anil Kumar Pillai sir has answered Nagireddy sir. There is another question from anonymous
Yes, sir.
person. For OPC, earlier IST is about 45 to 50 minutes, but now it is going up to 100 minutes. Why? He's asking. He or she, we don't know. Anonymous. Thank you.
If you look at the Bureau of Indian Standard, they just specify initial sitting time as 30 minutes and final sitting time as 600 minutes. So mostly whatever is available in the market, it varies over a range actually. The thing is that it will not go below 100 minutes. Normally you will find that it is between 100 to 150 minutes is the initial sitting time. And the final sitting time may be around 170 to 200. There is a overlap also sometimes. But definitely there is a change. There is a range. It changes over a range actually. It is not an absolute value.
Sir,
Yes, sir.
I think if there are not many questions, then we'll close this session. Nandakumar, no more questions, Nandakumar ji?
Yes, sir. No more questions, sir.
Okay. So I think there is a limit to the number of questions when we interact virtually. And most importantly, virtual interaction is more challenging.
Sir, Mr. Anil Kumar sir has delivered a wonderful lecture today and has given a lot of insights into cement and what the customers need to look into actually. And especially from the Readymix point of view, what the users have to look into, Mr. Anil Kumar ji has explained. And we thank you, Anil Kumar sir. We are really honored to have you on this platform. Qcrete is really privileged that you came on our platform with a very short notice and invitation. And we also thank participants for coming to listen to today's lecture, leaving all your regular jobs. And thanks for all of your encouragement. Thanks to ICI Mangalore chapter, Anil Baliga and his team for making this possible. And from Qcrete, I thank Mr. Kanishk and all at Qcrete who have made this event possible. Once again, we thank you, Anil Kumar sir, for this wonderful.
Thank you for giving me this opportunity of interacting with all of you. In fact, I'm sure that Qcrete also has a lot of knowledge as far as cement and concrete is concerned. And we are also honored to be part of this webinar, sir. Thank you so much for giving us this opportunity.
Yes, sir. We will again invite you, sir, maybe after 2-3 months with another chapter.
You can just tell me a topic because I am confining myself to the particular topic only. That's why. That's the reason. Cement is cement only.
Anil Baliga, sir, thank you.
Thank you, Anil Baliga, sir. Thank you. Thank you for coming, and all others from Mangalore and other places who have joined in spite of their busy schedule. Thank you so much, sir. Have a good day.
Thank you. Thank you. Thank you, Anil sir.